So we are going to be talking about solutions, Unit 9, and the first thing that we want to talk about is solvation and dissociation and kind of what this whole thing means. And so in order to talk about how things dissolve, we need to get on the same page about some basic vocabulary. So the first one is solute. So solute is the particles that are being dissolved. So this would be like sugar in Kool-Aid, or it could be talking about how salt is mixed with water to create salt water. But the main thing that I want you to understand is that the solute is always going to be your smaller amount, okay? Whereas your solvent is always going to be your larger amount, because the solute is the particles or the chemical that is actually doing the dissolving, if that makes sense. So, for example, water is called the universal solvent, and that is because it can dissolve almost anything if given enough time. Okay, so normally if I ask you, for example, let's say I tell you you have 65 grams of sugar and 100 milliliters of water, and I'm mixing them together, and I ask you, okay, what is a solute and what is a solvent? Well, as soon as you see water, water is always the solvent when given a choice. But not all solutions are going to be, something plus water, okay? Because a solution is really any homogeneous mixture. So homogeneous mixture, which I'm actually going to put that at the bottom, saying that a solution is homogeneous, meaning that it looks, all the parts look the same, but it's a mixture of the solute with a solvent. Now, like we said, water is the most common solvent, but not all solutions are just liquids. So, for example, you could have air. Air is a homogeneous solution. It has a mixture of nitrogen, hydrogen, oxygen, carbon dioxide, dust, all that kind of thing. But because nitrogen is about 70%, we say that nitrogen is our solvent, and all of these other things are the solute that is being mixed into the nitrogen. Or for example, if you had steel, steel is a mixture of iron, carbon, and maybe one other thing I can't remember, but pretty much iron is like 65% of steel. And so that would make this our solvent, whereas carbon would be our solute, because there's less of it than there is of the iron. So whichever chemical or element that you have the most of, that's going to be your solvent. And the smallest one is going to be your solute. And so that's kind of like what a solution is. So it's a mixture. It's homogeneous, meaning when you look at it, it all looks the same, but it is indeed mixed up. There are multiple pieces. So when we talk about how things dissolve, okay, not all things dissolve in the same way. So if my solute is ionic, then it's going to dissolve a different way than if the compound were covalent. And so they both dissolve though, and they both dissolve in water. However, they don't dissolve in the exact same way. And so as a reminder, this is something we learned about in first semester, so Unit 5 of first semester. So if you wanted to look back at a previous video on Unit 5 about ionic and covalent, you can. But just as a reminder, an ionic compound contains a metal, a nonmetal, or a polyatomic ion. Typically, though, we'll see it where you have a metal and a nonmetal. Whereas covalent compounds are compounds that are only going to contain non-metals. And as a friendly reminder, if you're saying, well, I can't remember how to tell if something is a metal or a non-metal, on your periodic table, which this is a beautiful drawing, there is a staircase. And anything on the left side of the staircase is a metal. And I'm going to highlight non-metal in blue because anything on the right side of the staircase is a non-metal. Now, the great exception to that is over here we have good old hydrogen, and hydrogen is actually a non-metal. So it's the one that kind of trips people up. So if you're looking at something, for example, like NaCl, we'd say NaCl is ionic because we have a metal with Na and we have a non-metal with chlorine. Whereas something that is covalent, a really common one, is sugar, C6H12O6. And all three of these elements are nonmetals. And so when we talk about dissolving, okay, there are two processes, and we do have some like more sciencey vocabulary for it. So the science vocabulary word for dissolving is solvation, and this means that the solvent, so that the how do we want to put this concisely? Solvation means that the solute particles are separated and surrounded by the solvent, okay, which again is typically water, and we'll talk about pretty much only water as being our solvent in this unit. And so solvation is just the process that happens, that water separates the particles and surrounds the individual particles so that they can't get back together. This is why it looks like sugar disappears when you mix it with water, because the particles get separated so much that you can't even see them with your eye anymore because they're not grouped together. And so the phrase like dissolves like describes how polar solvents will dissolve polar solute particles, whereas non-polar solvent particles is not going to dissolve. And so keep in mind, again, this is vocabulary from first semester, that all ionic compounds are polar, and water is the most common polar solvent. Now, when we talk about why water is polar, remember, water is oxygen surrounded with two covalent bonds to hydrogen, and so it is covalent. However, water has a high electron density around this oxygen, and its electronegativity, or its strength in being able to pull the electrons, is much higher. So what happens is the electrons that are inside these bonds get pulled towards oxygen more often, and so that means that oxygen will have a partially negative charge, whereas these hydrogens are going to be partially positive because the electrons that hydrogen have don't spend that much time with them. And so it gives them this partially positive thing. So these partial positives and negatives give it that polar quality that we're looking for. So it means water's really good at dissolving things that have polarity. So ionic compounds have positive and negative ions, cations, anions, things of that nature. And so what's unique about an ionic compound is that when ionic compounds undergo solvation, when they're dissolving, they also go through dissociation. Now remember, if you're saying that you associate with someone, it means you kind of have a loose connection. But when you're dissociating, that means you're breaking a connection. And so this means that the particles, the formula units of salt or whatever ionic compound you have are going to break into the ions. Okay, and so that means instead of one salt particle or formula unit being separated from another salt particle, that will happen, but it will also break down the formula unit into its ions. So you'll have your cation and your anion that are going to separate. And remember, cats have pause, so cations are positive, anions are negative. And so if you look here, you'll see that at the sodium chloride, typically, if we had just sodium and chlorine together, this whole thing is one formula unit of salt. And so that would be our particle. It would just be a formula unit. And when it dissolves in water, it would break apart. However, because it's ionic and water is polar, the attraction between the negative oxygens to the positive sodiums is so great that these waters can pull apart the sodium and the chlorine. So these sodium and chlorines, the attraction between that positive sodium and negative chlorine gets broken, and the water surrounds it. Now, keep in mind that when you look at sodium and chlorine, the oxygens with their partial negative are what's surrounding the sodium, because negatives are attracted to positive charges, whereas the chlorine, our anion, has the hydrogens surrounding it, because the hydrogens all have this positive charge. So water surrounds an ionic compound in a very, very specific way. And so that's something that you want to keep an eye out, because if I ask you about how it dissolves, you want to pay attention to what is being attracted to what. So positives are attracted to negatives. Okay, and so in class we watched a video. I'll put that video in the playlist for this YouTube channel because another person made the video, I did not. And so one thing that you want to keep in mind is when we're looking through these questions, you can answer them just based on what we've talked about, but you should be able to, you can pause the video and answer them yourself, and then I'll go over them. So take a second, pause. Okay, so sodium chloride is going to be ionic, and that is because we have a metal plus a nonmetal, okay? And then we know that the element in water that is negatively charged is going to be oxygen, whereas the element in water that's positively charged is hydrogen. And when we look at which element in water pulls or attracts the sodium ion, well, sodium is positive because it has that one valence electron that it's going to give away. And so it's going to be attracted to the oxygen, whereas the hydrogen is going to be attracted to the chlorine's negative charge. So that is going to be all for this video, but in our next video we're going to look at how to actually draw what happens between salt and sugar with solvation, and so keep a lookout for that video.